Let's talk about how to convert back and forth between the rectangular way of thinking about vectors and the polar way of thinking about vectors. So here I've got a rectangular form of a vector that has a displacement of 3 over and 2 up, and you'd write it that way. So if I wanted to rewrite this in a polar form, I'd need to know what's the distance and what's the angle. So what total distance do I walk along this line, and what's the angle above the horizontal? So this is a basic application of stuff you already know about triangles. So here, clearly this is a right triangle, and you know 2 of the legs, so Pythagorean theorem tells you this third leg. So if this is a distance and this is an angle, I can calculate the distance as the square root of 3 squared plus 2 squared. What about the angle? So I know that the tangent of theta is 2 divided by 3. So tan theta equals 2 divided by 3. But I want to isolate the angle. I want to get theta by itself. So I need the inverse because I need to undo the tangent function. So the inverse tangent is written this way, tangent to the -1. But remember, that's not an exponent. That is the way that you denote inverses. And that's it. And if you want to know what actual number this is, you can evaluate it on the computer or with a calculator. So in general, if we've got a vector in rectangular form with a delta x and a delta y, if you want to solve for the distance, which is written this way with 2 absolute value bars, the distance is always calculated using the Pythagorean theorem. So it would be delta x squared plus delta y squared. And the angle is always going to be the inverse tangent of delta y over delta x. And these are the formulas that you might see written in a textbook. One more thing is, this is called the magnitude of the vector. So the magnitude is just another word for the length of the vector, the length of the arrow. All right. So what about the other way? What if I have a vector in polar form where I know the distance I'm traveling and the angle I'm traveling at, and I want to convert it to rectangular form where I figure out what are the xy components? Well, this is again just a simple application of trig. So I know that the cosine of theta equals this delta x divided by r. So if I want to know what delta x is, I just multiply by r on both sides, and I've got delta x is r times cosine theta. Same reasoning applies here. Sine of theta is delta y divided by r. Therefore, delta y is r times sine of theta. I can't tell you how many times I have programmed this while making video games. You might be wondering, why do you want to convert back and forth between polar and rectangular? And that's going to be really clear pretty soon. Some types of things you want to do with vectors are really easy if they're in polar form. Other types of things are really easy if they're in rectangular form. So depending on what you want to be doing, sometimes you might need to switch back and forth between the 2 forms so that you can do the thing you want to do and then go back to the other form if that's the way that you want to report your output.